Okay. Well, I appreciate everyone joining today. Hello, everyone. This is actually the first of several webinars in a series featuring Industry 4.0 solutions at Sage Clarity. Today, we will show you how to supercharge your Informance deployment with what is called Abel. During the webinar, feel free to ask questions you might have using the GoToWebinar panel options. We will monitor those questions to answer at the end of the webinar. Today's speakers are John Oskin, President at Sage Clarity, and Mark Bertrand, Vice President of Products, also from Sage Clarity. As an Epicor channel partner, Sage Clarity develops solutions to enable the hyper-information enabled enterprise of the future. John has more than 20 years manufacturing and supply chain experience and was the founder of Informance International. Mark is an experienced professional in implementation with IIoT enterprise manufacturing intelligence to drive continuous improvement in manufacturing operations, quality management, and supply chain processes. Take it away, John.
Thank you. So today's agenda, we're going to start by talking about the Informance data capture elements that already exist and how that will be improved with Abel, this new technology we'll discuss. We'll explain it in detail. We'll talk to you about why Abel is beneficial to the business. And then we'll talk a little bit beyond auto tagging and the use of Abel and some of the future capabilities for you to think about. So let's start with a basic understanding of tagging, downtime, and informance. As most of you know, informance has 4 levels of downtime reasons, with a 5th level called super reasons. Informance customers do a great job at the 1st and 2nd levels. However, tagging starts to degrade at the 3rd and 4th levels. And Abel is going to give you better fidelity at those deeper levels. Informance also has 4 levels of deployment. So level 1 is manual data collection, which is usually a starting point with no automatic monitoring of equipment. Level 2 is what we call semi-automatic, typically where you monitor the constraint operation. In a CPG operation, that would typically be the filler, and downtime reasons are manually assigned by an operator. Level 3 is the first automatic level, where we monitor all the assets automatically. We provide 1st, 2nd, 3rd, and 4th level reasons automatically, and then the operator can provide additional insight on that auto tagging element. And then finally, level 4 is fully automatic. So monitoring all assets automatically, no operator involvement. And it's these last 2 levels, level 3 and level 4, that we're going to be discussing today and how that gets enhanced with this Abel auto tagging technology. So I also want to get into a little bit of discussion around Informance primary and secondary assets and how Abel leverages that hierarchy. So starting with the primary asset, this is usually at the line of machine where we calculate OEE. So it's usually that bottleneck point for OEE capture. It typically has a rate associated with it, and it's also subject to level 3 or level 4 deployment from our last slide discussion. Secondary assets and informants are where we get additional details now at the unit op level. So if I've got an operation with a filler, a cartoner, and a case packer, this would be the cartoner and the case packer and those secondary assets that we're talking about. In this case, we're tracking uptime and downtime only typically, and it's independent of the primary asset. Rate standards are typically not used on secondary assets because, again, they're just focusing on the downtime element that you're trying to isolate around that asset. And then finally, operators typically don't tag those. And this is kind of where PLC auto tagging comes into play. So what does Abel do? Well, Abel auto tags downtime and informants. It does this with no modification to PLC logic. That's an important concept. So line and machine states, counts, fault locations are all processed in our logic engine, and that information is passed to informants. This technique allows for remote deployments. So as I mentioned, informants customers do a great job at 1st level tagging. However, it starts to degrade at those lower levels. one of the early client deployments we did a study on, and we learned some key statistics. The first is that we found that Abel had a higher fidelity to the tune of 20% higher in the data over the manual tagging effort. And this is when considering that second, third, and fourth level. So if you think about informants tagging, 95% plus at the first level, what we're saying is that at that second, third, and fourth level, it really gets enhanced when you start auto tagging this information automatically. The other interesting statistic was around integration costs. So Abel has a 50% lower integration cost from traditional methods, and it doesn't require the same expertise as using a PLC controls engineer. So I'm going to turn over to Mark now to talk a little bit more around how you can supercharge your deployments with informants and get into more of the details.
Thanks, John. So Abel can do a number of things to enhance your informants deployment. So I want to explore a little bit about how it works. So Abel is a modeling tool, and it supports a robust multi-level auto-tagging profile. And it does this through the use of some intuitive interfaces and standardized logic. So basically, one of the things we're doing behind the scenes is we're handling all the overhead of interfacing to informants. And what this allows you to do is to focus on building a high fidelity model for your machines and your overall line. And one of the things that John touched on is key is that this is all done in the product, so it does not require PLC code. And I spent a lot of my early career in plants, deploying logic, validating logic. It saves a tremendous amount of time. So the way we do this, I'll just touch on these briefly and then we'll go into a little bit more detail, but we start with machine states and faults. So we need to figure out what states the machines are in and what type of faults are really relevant to our model and how to map those into loss tree. Then we layer on a second level of logic to model the overall line flow so we can determine a root cause at the critical or choke point of the line. Then we also, in some cases, will go as far as monitoring the conveyance. So we can actually look at conveyor zones. We can look at counts for machines, count in, count out. We can look at rejections. So we can aggregate this data, transmit some to informants, or keep some of that just for more data validation purposes. So that's really the core of the model on the left-hand side. On the right-hand side, we start with enterprise configuration management. And what's really important about this is that we store all the configurations in our cloud site. It's all kept very securely. But what this allows for is to transport models or templates between plants and lines. So this creates a higher degree of reusability, and it also gives you a time savings by leveraging things that have already been proven. We have live graphics and diagnostics. One of the biggest challenges of validating an auto tagging system is determining, is it really doing what it's supposed to do? We'll show how these live graphics assist that process tremendously. And then finally, it's an IoT ready solution. So we are using Industry 4.0 technology. This has been featured in a couple of different magazine articles, but we are following the Industry 4.0 roadmap. So a little bit more detail here on how we approach this model. So we implement a modular approach, and the overall line is broken down into key machine centers or unit operations. So once we determine what those are, the first thing we have to do is apply a state model to each one of these. And the key thing about this state model is separating internal versus external delays. We need to do this to decide what we're going to blame the machine for versus what we're going to look for outside cause. So once we've determined those states, which are represented on here on the screen, we can break some of those down into more detailed reasons. So you note at the bottom, there's two different internally fail states. Those are two different reasons we would want to capture. But what's key here is that we're looking first for external delays, like blocked and starved, and those can be tied to root cause links. So basically we can say, well, if I'm starved, I'm going to look at the upstream machine center to propagate a root cause. And then lastly, we're able to embed the logic in the same place. So everything's all stored in the same place. What the reason mapping is, what the logic is, it keeps it all together, which is fundamentally self-documenting. So this is the second layer. So once we've actually created those machine models and we've created those linkages, this is an example of how it actually works. So in this example, the critical machine is the filler, as John mentioned. That's very common in CPG. That's really where we want to measure the overall line impact. So in this example, what happened was the initiating event was a cartridge box jam. What happens as this moves through the line and blocks the different machines, such as the labeler and the capper, is they grab that root cause and they move it forward. And this is an algorithm we call progressive root cause. It's much more accurate than other algorithms because the previous models would always try and figure out at the time something goes down what caused it. This is actually taking it through the line flow. And so the ultimate result here is that the line downtime cause will be carton or box jam.
So as Mark mentioned, Abel has a cloud configuration utility. So what I've got on screen is actually the live application now. And this supports a corporate PLC standardization strategy, by the way. So a couple of thoughts to think about here. First of all, historically, PLCs simply controlled machines. In the 90s, data acquisition logic was added, and this was a good idea, but now PLCs are overwhelmed with data needs. So since Abel doesn't require PLC programming, it really takes PLCs back to their roots, doing what they do best, which is controlling machines. And that leaves Abel to handle the data acquisition and event processing. Let's take a look at the configuration utility now. So what you're seeing on screen here is we have the canvas in the middle, where we've got a line layout, and then on the left-hand side are where we have assets. And the process for creating a configuration is really a drag and drop process. So we're going to start by dragging an orienter, a filler, and a labeler onto screen here. So I'm going to grab one of these orienters and bring it on down in the canvas. I'm going to grab a filler and bring it on down. And then I'm going to grab the labeler. Okay, so we'll grab a labeler, bring it in. And then what you do is you start connecting these up. So I can take the orienter and I can connect it into the filler. I can take my filler and I'll connect that up into my labeler. If I have multiple labelers, as you see above, I can branch those out and bring them back together. So you get the idea in terms of how we're trying to build the connectivity and relationship between these machine centers. Okay. The next thing is if I click on one of these assets, I get some details. So Mark, tell us a little bit about the details here that we're seeing related to asset definition, item definition, and conditions.
Yeah, so one very key thing here, John, is that we have no programming. One of the things that is often a concern about new technology is we have to learn how to program this new piece of technology. Everything here is configuration based. So this is a simple set of drop-down lists which allow you to select which PLC you're going to primarily pull your data from, the reason list, so that once you're inside this machine, you can just pick from a drop-down and assign reasons that are valid within the Informance reason list. There's some organizational things like assigning it to an area, assigning it to a line. There's ability to bind to a template, so to inherit things from a template as that thing is modified. But everything is very simple in the fact that you are setting this up just through picks. So once you've created that, the next thing we set is items. And items really represents the interface of the PLC. So this is the one place where you need someone with a little bit of automation knowledge. Someone needs to import these tags. So this is really what sets up the interface of the PLC where we're going to create all of the logic. And then lastly, we go to conditions. And this is something we touched on earlier. So these are the actual conditions for a machine. You've got some things that are more out of service. We handle like non-communication situations. We handle planned non-production. So we can have a single flag that takes an entire line into like a non-production for changeover or whatever that is. But then if we get down into the actual reasons, just like before, we've got our external delays first, and then we've got specific faults, which can be as few or as many as needed to represent a high fidelity model. We build the logic and the condition information. John, if you hit like edit on one of these conditions here. One of the key things here I think is very important is one of the biggest issues in creating good fidelity between the auto tagging system and Informance is making sure you marry up the codes, because the interface is all based off of handing off a reason code. So here we're able to pick right from the loss tree. So if you click on that, these are all the different reasons built into the loss tree. And that's imported directly from Informance. So that ensures proper cohesion between the two systems.
So the completed configuration is really best understood with Abel Live. So Abel Live is an application where we've got real-time visualization of the data now. So a couple of points here. On a very long line, a visualization like this is good for operators that don't have line of sight visibility from one end of the line to the other. So if you're sitting here at an unscrambler and you're trying to figure out what's going on at the other end of the line at the palletizer or the case packer, and you can't see the other end of the line, this visualization helps with that effort. So what we've got here is we've got a little bit of a simulator. So what I'm going to do is I'm going to start, and I'm going to start by taking the packer out of commission here. So this will kind of simulate a downtime event that you might see, you know, on the actual production line. So you'll notice that when I take the packer down, it turns red. So that piece of equipment is now down, and you can start to see here downstream, the system's getting starved. So my palletizer is getting starved in yellow, and then upstream, things are starting to turn orange because they're blocked, because nothing can get through. And that will continue to propagate through the line. So, so you can kind of see that here on screen. And then most importantly, what you'll notice here is that the overall line asset here, which is really kind of monitoring and scanning the overall line, it's picked up the fact that the root reason is the case packer, and it's interrogated the case packer, and it knows that the open flap fault was the secondary condition associated with that piece of equipment. In addition to that, I can click on any one of these assets here and get more details. So Mark, tell us a little bit about some of the details at the data record level that we're looking here.
So it's just huge for data validation, because one of the key things about Abel is we apply no microstop threshold. So we will register, you notice there's an event there start, it's 1 second, there's another one that's 2 seconds. So we get very, very high speed processing because Abel is connected almost in real time to the controllers. So we're able to look through this data and reconstruct sequences of events to say, this was blocked at this time, so now I can look at the next unit operation and see if that root cause made it to it. Because one of the biggest challenges, you know, once you've gotten your machines right, is making sure that this root cause truly models the conveyor flow. Because there's always certain conveyance scenarios which you don't think of when you're constructing the model, like check weighers in between, things like that. So this is what helps us go through the data. But what's also really important is a legacy of the system we leave behind, because if we're doing the integration, we handle this data validation process, but things are always changing in the automation, things are always changing in line flow. So this is a tool for the end user that's very intuitive, that they can go back and revalidate what's going on.
Thanks. So back to the PowerPoint. So hopefully that was helpful in terms of sharing with you the a little bit of a live example of Abel in action. And now what we'll do is we'll kind of talk a little bit about how this integrates in with Informance in its final state. So Abel can actually be embedded onto the Informance IFA or operator interface, and it really gets launched through a button where you can bring up these live views. That's actually helpful if I've got a PC on the shop floor where I want to kind of look at this information, or we actually have a phone application. So with the phone app, it brings up the same data, but it's formatted for a phone. So if you're a supervisor and you're trying to figure out what's happening right now, the phone app actually gives you a nice real-time representation of that data. So in addition to food and beverage and the fast-moving consumer goods sector in general, The application has applicability for other industries, automotive, electronics, other discrete manufacturers, and for pharmaceutical and medical device manufacturers in particular, there's unique value. And this is related to it being in a validated environment. Because Abel is a passive data collection system and no PLC modifications are made, revalidation is also not required. So the implication in that industry is that it can save many months of validation time and hundreds of thousands of dollars in validation costs. So to kind of wrap up, so why Abel? Well, a couple of key things. It eliminates the need for a data concentrator PLC if you were to do this in a more traditional fashion. It eliminates the need for PLC programming, as we discussed. It provides a standardized approach for auto tagging, a very important concept for large multi-site customers with a number of plants in their network. It provides a cloud-based configuration utility that we saw today. And most importantly, it accurately identifies and tags downtime at the component level, which gives you overall improvement in fidelity of the information. At the end of the day, it improves data fidelity by up to 20%, and we've seen integration costs get reduced by up to 50%.
Okay. Thank you, John. Thank you, Mark, for sharing your thoughts on where we are going with Industry 4.0 and how to supercharge your deployments with Informance. Hopefully everyone recognized we covered a powerful piece of this technology called Abel. We actually have a series of webinars coming up, so we invite you to those. In our next webinar, we will extend the topics of Industry 4.0 to more intelligent alerts and our next generation andon. If you're not familiar with the andon, it was a Toyota concept from the 50s for raising awareness on issues. Our next generation andon technology works really well with Abel to create intelligent alerts from the machines, as well as email notifications to appropriate users. The trouble tickets that created from the andon system then get tracked just like downtime events. So we welcome you to join us at the next webinar in our series. As far as questions go, we appreciate your questions during this webinar. Hopefully we're able to answer what those were. And if you do want to follow up for more information, please feel free to visit our website at www.sageclarity.com or email us at clarityteam@sageclarity.com. Thank you again, John, Mark, and our attendees for joining. We hope you have a great day.
We'll pause now.